please join me in welcoming to Distinctive Voices Dr. Kirk Smith.
Let's get this working here. So it's very nice to be here, and thank you for coming out this evening. You can tell it right away it's not a student audience because you'd all be sitting in the back. Now, I don't know if you know that sitting in the front's a good idea to see things better, or it's just, you know, at our age the hearing is a little bit different. But and Woods Hole is my wife. I mean, we know it well. Woods Hole. My wife used to work here, one of your venerable scientific institutions, the Woods Hole Research Center, which is right out here on Woods Hole Road with the big windmill there, and she had a really nice place on Fay Road on the beach there. So special place for us. Those couple of years she spent here, I had to commute, but spent a lot of time here. So I want to talk about something that well, you can see the topic here. It's, I think, I say surprisingly because most people are a little bit surprised at the scale of the impacts, and I understand that the procedure usually here is if there's a burning question, please raise your hand during the talk. Otherwise, we'll have a question and answer period at the end, and I guess some coffee together and things afterwards. So the roadmap, what I'm going to talk about, what is the world's oldest occupation, and it's not the one you usually think of, and how important today, why so much health impact, what is the climate impact, and what might be done. So the oldest occupation is cooking, and I can say that with some confidence because the definition of the moment that we became human from pre-human is often used as the moment we learned to control fire. So by definition, it is the oldest occupation. The first minute of being human was the minute taken in cooking. So, and only recently, surprisingly, they actually figured out when this was. Not so easy to look at archaeological sites that have charcoal or not, or, you know, whether, you know, and this extensive review by these scientists here pinned it down. You might call that not all that pinned down, but at least it's we know roughly how long this has been going on. Generally the type of fuels I'm talking about are what we call solid fuels, that is, and these are the main ones: wood, crop residues, and coal. Coal is widely used in households in China, but not many other parts of the world today. Here is the distribution of usage of household fuel, solid fuels for cooking in 1990 and 2005. I know you can't really see the trends here, but this is an estimate of the trend. Here you can see the world population using, now, and this is for cooking. I'm not speaking of space heating. A lot of people in this room may be using wood for space heating, but you don't use it in open fires for cooking all year. So this is the total population, which is steadily rising, as you know. And here's the population using solid fuels. Now, this illustrates a sort of a dilemma or didactic or a sort of a dialectic, really, of development. Are things getting better or worse? Well, if you look at the fraction, they're getting better. A smaller fraction of people are using these fuels than in previous times, right? So that's better. On the other hand, if you look at the absolute numbers, they're still going up. And in fact, more people are using solid fuels today for cooking than ever in human history. And since we live on a finite planet, it's the absolute numbers that count, not the relative ones. And if you're poor, it doesn't really matter if there are now 3 people who are rich instead of 2, you're still poor. So I would argue that the absolute numbers are the right ones to think about when you're talking about things like poverty or environmental impacts. It's generally almost 100% related to poverty. Here's the distribution of solid fuel use in India, from the poorest 20% to the highest, to the richest 20%. And you can see all the poor people use solid fuels and none of the rich people, or very few rich people. And then as people get richer, they shift to gas and kerosene for cooking. So it is associated almost 100% for poverty. In fact, if you had a quick definition, somebody emailed you from Mars and said, I'm visiting tomorrow afternoon, how do I find the poorest people on the planet? tell them to look for people who are cooking with open fires in their houses. Those are the poorest people on the planet. In the case of India, that's 160 million households today, up to this point. So, in history, 40% use solid fuels, about 2.7 billion. Sorry.
Excuse me, just a basic question. You reckon LPG as a solid fuel?
No, LPG, sorry, is a clean fuel. Liquid, it's a gaseous fuel. So here are the solid fuels, sorry, and here's the clean fuels coming up. LPG is liquefied petroleum gas. That's the international designation. You probably know it as propane. And it is the first clean fuel that people often shift to in poor countries. Sometimes kerosene, but usually LPG, liquefied petroleum gas. I mean, our liquefied petroleum gas is all propane, you know, what you use in your barbecues. In most of the world, it's a mixture of propane and butane. Why is that? Well, because we take the butane and dissolve it in gasoline because we're so short of gasoline in this country that we need all the help we can get making gasoline. But most of the world, it's a mixture of propane and butane. All right, so 40%. Percentage is dropping. The absolute number is rising. Perhaps 10 to 15 million people a year are added each year using these fuels. More people using today than any other time in history. In fact, more people today using these fuels than there were people in 1950. Or any year previously, obviously. So now, some people think of, will say, well, how can wood smoke hurt you? I mean, it's natural, isn't it? I like the smell of wood smoke. I like it a little bit too, I mean, in moderation. Well, I hate to remind people that natural things are actually fairly nasty. I mean, snake venom, botulism, malaria, tsunamis, I mean, you know, name it. In fact, most of humanity has spent most of human history protecting ourselves from natural things. It's only a very small number of people in which we represent where we can have the luxury of thinking of natural as benign. And in fact, if you go to the drugstore, all those products labeled natural, you're not only supposed to think they're benign, you're supposed to think they're good for you. All right, so being natural is not, yes, it is natural, but that doesn't guarantee anything. Somebody knows a little more will say, well, when you burn the wood, since wood is just carbon, hydrogen, and oxygen, basically, and you burn it, doesn't it just change to CO2 and water? Benign substances, more or less, at least for health. That's, in fact, the first, back in 7th grade chemistry, that's the first formula you looked at, the burning of, carbon, CO2, and water. And that is, in fact, true, but the problem is, and this is the single biggest problem with this, something to remember, is it doesn't burn completely, unfortunately, in small combustion devices, like a fireplace. You've seen that it doesn't burn completely. Now, your smoke goes out the stack, but it might sit in your neighborhoods. And if you're barbecuing outside, it goes in your face. But you're not doing this day in, day out in your entire life. If you would have kinds of impacts on health that we see in other countries. The problem is the combustion efficiency is that far less than 100%. A lot of the carbon in the wood doesn't get turned to CO2. What does it get turned into? Well, here's a typical Indian cooking stove, 1 kilogram of wood per hour approximately. Here I'm measuring it in terms of energy. This is an energy unit, megajoules. 18% of the energy goes into the pot. That's what you're after. 74% of the energy just goes waste heat into the room. But 8% is not even burned. Stays as products of incomplete combustion, partly burned. 8% of the carbon in the wood, in other words, is turned into these products of incomplete combustion. I call this a toxic waste factory. I mean, I don't know what you mean by a factory, but it takes a benign substance, wood, eat it won't hurt you, and turns it into toxic substances, depending on the stove, 6 to 20%. It's a very inefficient process. Of course, as it loses the heat, too, that's another energy efficiency part of it, but I'm talking here about the health impacts. Now, am I exaggerating to call this toxic waste? Well, let me show you what's in wood smoke. These are from a review we did not so long ago, and looking at what has been documented in wood smoke, mostly from studies in the U.S. and Europe, actually, but the wood smoke, composition is pretty much the same everywhere. And I know it's a vast range of chemical, terminology, but all of the things in italics here are known toxic materials, maybe some of your favorite things like benzene and formaldehyde. some standard air pollutants like small particles and carbon monoxide and NO2, even such things as dioxin that people think of it as industrial chemical. You know, you hear about the accident, the Cerveso accident in Italy and so forth, the dioxin. It's actually, we've been doing measurements at our site in Guatemala, and we find substantial amounts of dioxin in this wood smoke. So one way, if I wanted to exaggerate a bit, and it's not exaggerating, if I want to be alarmist, it's not exaggerating, I could describe this mixture as this. It has mutagens, immune system suppressants, severe irritants, inflammation agents, central system nervous suppressants, ciliotoxins, endocrine disruptors, neurotoxins, human carcinogens, and other toxic inorganic chemicals. Now, if I was, alarmist, that's the way I'd do it, and I wouldn't be wrong. You can't measure everything all the time in mixtures, so we use small particles as the best indicator. Now, does this mixture remind anybody of anything? Very good. I always tell my health students that anytime a professor asks a question you don't know the answer to, just say tobacco and you're likely to be right. And yeah, it's very similar. I mean, cigarettes, burning biomass, incomplete combustion. Same stuff, some different mixtures. There's one big difference, however. Of course, there's no nicotine in wood smoke. I dare say if there's nicotine in wood smoke, the world would be a different place. I guess the good news is there'd be no tobacco companies, no need for them. Bad news, there'd be no forests, but people would smoke them all. But generally, it's a very similar mixture. And remember that, because I'm going to come back to this idea. All right, one thing to have a lot of stuff coming out, but what do people, the concentrations, the amount that people breathe in, important? Well, here, again, that's our typical Indian wood stove, and you can see, I know you don't know, these are just a few of the toxic chemicals. And here are the health-based standards for those chemicals, and here are the typical indoor concentrations in India during cooking. And I don't need to know what these numbers mean to see that these are a lot bigger than those. Well above anything that anybody would call health protective. And just to remind you, these two particular chemicals are classified as, definite human carcinogens by the International Agency for Research on Cancer, the body that does decide on whether something is a carcinogen formally. But we don't measure everything all the time, so we try to measure particles. That's exactly what the cigarette people do. If you look at a pack of cigarettes, it says tar content, right? What's tar? Tar is the cigarette people's way of saying what the air pollution people call as small particles. They capture it on a filter, the particles, like we do. It looks shiny, so they called it tar 100 years ago when they first looked at it, and now it's called tar, but it's the same stuff. It's the same small particles that we use in air pollution. Well, one thing, again, maybe, if nobody's exposed to it, in health we don't really care about emissions or, concentration. Somebody has to be there to breathe it. And this is, I think, the first person in human history to have her exposure measured during the oldest task in human history. This is a study we did 30 years ago in India. And here you can see she's wearing a pump, and she has a little filter here, and then air is being drawn through the pump, through the filter, right in her breathing zone, so you're getting a good idea of what she's experiencing. And then you take the filter afterwards and weigh it and analyze it to see what she's exposed to. So we've done a lot of this since, but this is the very first one. This was just about at the moment in human history when, for the first time in human history, half of households were doing something else besides this. All right, now we understand a lot more about these impacts, and here's a recent model that we're just publishing now on the average concentration inside village kitchens in India. And I know you don't know these numbers, but just by comparison in the same units, the EPA standard for protecting health is 15. The WHO guidelines are in the same range, well above anything. Mm-hmm.
What do you achieve?
Micrograms per cubic meter. Sorry, that's the metric here. Millionths of a gram per cubic meter of small particles. And so this is what we find in the kitchens, and these are what standards have been set to protect health, either by U.S. Environmental Protection Agency or by the World Health Organization. So, well above anything that has been considered that might be protective of health. So, what about health effects? Well, we don't have time to talk about them all by any means, but let me show you what kinds of health effects we found, and what they're the same health effects we find with smoking. Not as big as smoking. Obviously, the worst thing you can do is take your kitchen fire and stick it in your mouth, which is what the smokers do. But this is about the second worst thing you can do. So, pneumonia in young children. I'll show you more data. Low birth weight, obviously in the mothers who are exposed when they're pregnant. Children are born at lower birth weight, and low birth weight has a lot of impacts on child health. Stillbirth, we now have a showing cognitive impairment. Our kids in Guatemala, we've been studying now for 7 or 8 years. They're 7 and 8 years old. Their performance on cognitive, it's called IQ in some cases. The official name is cognitive performance, learning ability, really. It's directly related to the exposures their mothers received during pregnancy. Sorry.
In the previous slide, you look like the first state you did the study in Gujarat has the worst.
Yeah, interesting, isn't it? No, I didn't know that at the time, of course, first study, but I hope it's not because I was there. But yeah, that's right.
Is that because there's less ventilation? Or because
Yeah, less ventilation, housing patterns, cooking patterns, fuel use, everything's a bit different. It's very hard to predict, really you have to measure. At least that we found that you do. So, in women, chronic obstructive lung disease, this is COPD, as it's called, or, emphysema, chronic bronchitis, obviously an outcome of cigarette smoking, one of the big outcomes. Cancer, lung cancer in particular. Blindness, cataracts in particular. Tuberculosis, and heart disease. And I'll talk a bit more about that. And obviously some things not related to the smoke specifically, but burns and health and safety impacts of fuel gathering. Women have to go out and spend long hours out in the bush collecting fuel, things like snake bite, violence, so forth. So a whole set of things associated with this activity. Now, how big is this compared to other things? Now, this is a big exercise run by the World Health Organization, published in 2004, new version being published later this year, but I can't show you that yet, but I can show you this one. And this is the top risk factors and how much relative ill health they cause. Now, the metric here is lost life years, not death, but lost life years, because we care more for the death of a 20-year-old than we care for a 90-year-old. How much more? Well, it depends on how many lost life years. So some people don't like that metric, but it's the international metric that's used. It also includes non-fatal, morbidity, illness, depending on how long you have the illness and the severity of that illness. So by this metric, the biggest single impact on health in the world was still malnutrition, mainly in young children. This is unsafe sex. That's the HIV epidemic, mainly in Africa. And then, some things that affect rich countries as well as poor countries: high blood pressure, tobacco use, alcohol, unsafe water and sanitation is the first environmental risk factor. That's basically human waste getting in the drinking supply in one way or another. Not vaccinating children against the known child diseases. High cholesterol, lack of malaria control. And here's indoor smoke from solid fuels, number 10 on the list. Now, I would, these aren't not so accurate that you can really say that this is, this one's bigger than that one and so forth, but you can see it's up there with the big boys. So that's sort of the point. And now, this first part of my career was actually in nuclear safety and nuclear waste and all of that sort of thing. You ask why I left that. Because my original training was in physics, and it's kind of natural to work on nuclear issues. I left it because the risk was too low. Now, you laugh. But the risk of nuclear power has nothing on these issues. Now, let me illustrate that. I thought about, the media discovered that I had an early career in nuclear energy, so I was fielding 15 calls a day after this Japanese accident a couple of months ago. I got thinking about it. So I said, well, what if we had a Chernobyl accident per month? Now, the Chernobyl accident was much worse than the Japanese accident. The Chernobyl accident is the worst possible accident you could think of for nuclear power. The power plant blew up in the middle, full operation. There was no containment. The thing burned because it was made out of burnable materials. The 95% of the radioactive materials was spread in the environment. Less than 5% is spread from Japan. The The Soviets tried to hide it, so they didn't do any evacuation. They didn't, give anybody any iodine pills and so forth until it was revealed, internationally that something was happening, and that was too late. So you can't imagine a worse accident, really, by the design of the reactor and the reaction of the authorities and so forth. So what if you had one of those a month? How big would it compare on this? Now, one of those a month, remind you, well, here, I'll show you. So this is the best measure of ill health. So authoritative estimates are that the eventual total death toll from Chernobyl will be 4,000 to 10,000, nearly all from cancer, from the radiation exposure. So I took the upper end of this estimate to say, all right, let's say it was the worst that we could think of. So we had 12 of those per year. How would that come on this graph? Well, there's Chernobyl. And you want to use deaths. Here's outdoor air pollution, only in cities. And here's, solid fuel use, using deaths instead of the metric. Although I think DALYs are a better metric, but anyway, they're all there for you. Now, I must remind you, of course, that if you had a Chernobyl accident per month, what's your estimate? 2 months? 3 months? We would have no nuclear power industry anymore, right? Meanwhile, this goes on day in, day out. Nobody pays attention. Of course, that's just one of the indicators of disparities in the world and of people who live at the bottom of the totem pole, and that probably poor rural women in developing countries, about as bottom on the totem pole as you can get, along with their children, aren't getting a lot of attention. But, of course, it's not as feared as radiation, for a number of reasons. But the actual impact. So you can see why I left nuclear power. Because I had trained myself to follow the risk. And it doesn't take you there. All right, what do we know? Well, this is some studies that have been done. I just put in. This is a study of chronic obstructive pulmonary disease, a very important cause of death around the world, highly associated with tobacco smoking, but also household air pollution. Now, this is a study in a prominent journal and a British Medical Journal. It's a little complicated. Let's just stick to the women's one. And this says the probability of not having COPD, whether you put it in an improved stove or not. And you can see if you put it in an improved stove, your probability of not having COPD was, much better than if you didn't have the improved stove. It also showed, however, that there was still some remaining risk for these women, that the chimneys didn't prove, perfectly for them, but still was a lot better than not having a chimney. Now, this is a bit more convincing than other kinds of studies because it's an actual intervention. Something was actually done, they put in improved stoves, and then you see the impact. Now, we wanted to do an intervention study called a randomized trial. Very early on, we decided to do this, and we decided that the best thing to look at was child pneumonia, because pneumonia is the chief cause of death in the world's children, everywhere. Chief cause of death in children in Woods Hole. Also in India, but except in India, it's 100 times higher rate. People think of diarrhea or malaria or some of the other kinds of diseases as being the chief cause of death. They're certainly important, but it's actually pneumonia. It's the chief cause of death. The jargon term is acute lower respiratory infection. So we decided we'd want to do a randomized trial, that this was the way to convince the international health community that we had a serious thing. So we did that first measurement study in 81. We had a meeting in 83. We decided to do a randomized trial. We started applying for money in 84. And 17 years later, we got the money. 2001, we finished the study in 2006, and we're just publishing the results now. So it's 30 years since the first measurements to this big study. So basically, how many have been to Guatemala? I was talking to somebody earlier who had been there. Well, this is a typical situation in Guatemala, open fire, mother with a baby on the back, and highly polluting setting. This is an area of Mayan Indian population, indigenous population, and we took 550 houses or so, and randomly, ended up with 518, but started with 530. I think it was 536, and randomly gave half of them an improved stove with a chimney at the beginning of the study, and the other half got the chimney stove at the end of the study. We followed the health of the mothers and children throughout to see if there was a difference. Now, why do a randomized trial? But because if you're just looking, for example, you look at a group of people who have a polluting environment and a group that don't have a polluting environment, and you find a difference in health status, well, that's some evidence, but there's probably other differences between these two groups. The groups that have the cleaner fuels are likely to be richer, or maybe have better education, or better nutrition, or better access to medical care, or different ethnic group, and so forth. So you're never quite sure that what you're measuring is actually the effect of what you're interested in, the smoke, versus what they call confounders, other things that affect it. And since fuel use is so closely tied to poverty, and poverty is so closely tied to a number of problems of ill health, you're never quite sure, although you can, do all sorts of fancy statistical methods to try to make sure that you've taken care of everything. But the only way to prove it, really, only in the sense of causality, is considered the randomized trial. So we also measured the air pollution that these kids and mothers received. Sorry for the Spanish, and with this new technique, we developed these using these little tubes. So we got the actual personal measurements of what they were receiving. I'm not going to show you the whole thing, but this is the results here, and here's the these are, we divided the kids into 10 groups. These are the 50 kids with the least exposure. These are the 50 kids with the highest exposure. This is medically diagnosed acute lower respiratory infections, the gold standard of showing pneumonia. And this is the exposure they received in micrograms per cubic meter. Now, just the way to think about this, because there's always a scatter in the data, is the curve that fits it. That's what you should look at here. And this just gives you the confidence, the statistical confidence around it. And this is which is pretty good for this. Now, first of all, notice this is per 100 child years. So a lot of children are getting, 1 out of 2 kids are getting pneumonia every year. That's a hell of a lot of pneumonia. That's why it's the first cause of death in these children. So even in the cleanest situation, the child that's getting, 25, one out of 4 kids is getting pneumonia every year. So we haven't solved the pneumonia problem with this, but we've reduced it substantially by bringing the pollution down. But it also shows something that's quite striking, and that is this is highly nonlinear. So you reduce the pollution from here to here, which might take a big effort. You're not getting much health benefit. And in fact, our open fire kids averaged here, and so that was their pneumonia rate. And our chimney kids averaged there, that was their pneumonia rate. So we got this benefit. But that was a factor of 2 reduction in exposure, but hardly a factor of 2 reduction in pneumonia. We now realize that a chimney stove may not be enough to really give you the benefits, and that you need to, you need to get down here to really get benefits. And there is a new set of technologies that I'll talk about later that we think will get us there. All right, I'm going to skip that. The reason, basically, although the kitchen got a 90% reduction in exposure, though we protected the kitchen with the chimney, if you will, the children only got a 50% reduction in exposure. Why is that? Well, the kid doesn't stay in the kitchen all day. And this stove doesn't eliminate the smoke, right? It just moves it. The chimney just moves smoke 1.5 meters or 4 or 5 feet. And it stays around the house. It goes in the bedroom. It goes next door. And when you think about it, we don't deal with environmental contaminants in this country by just moving them a bit. Not anymore, anyway. It's not considered appropriate just to build a taller smokestack or a longer pipe out into the ocean. We develop processes that eliminate the pollution, either with a filter or with processes that aren't dirty. Same here. In fact, it's even more important here because you're right in the household environment. So this is one of the lessons we got in this study. I mean, here you can see smoke doesn't disappear if it goes outdoors. So the personal exposures did not go lower as much as kitchen levels because the kids don't spend their entire day in the kitchen. The household pollution does not reduce the smoke. It just shifts it, moves it around. And the kid also moves around. So this is a little disappointing that chimneys alone, we got some benefit, but to really think about major improvements in health, we probably have to think about devices that don't produce the smoke in the first place. All right, well, let's think about, well, the smoke goes outside, all right, maybe it goes to the neighbors, but then what happens? Well, in fact, it continues to go. And here is 20-month average ground level, this is small particles from satellite data, so it's long average. And notice these two places in the world, heavy amounts of, this is outdoor air pollution now, from in the big, heavily populated but rural Ganges River Basin and the Yangtze River Basin and the Yellow River Basin. If you've ever been to China, you've been in those rural areas, far from cities, you'll see there's lots of pollution. What is that pollution from? You can see it from the satellite here, but what's that pollution from? Well, it's from brick kilns and agricultural burning, but a major source is the same incomplete combustion that causes problems in the household environment on its way out, but also leads to general outdoor air pollution. Yeah. Lack of data from these satellites.
Aren't there some areas in the U.S. that are very yellow?
Well, that's our. You've got particle air pollution down there in those areas. Southern California is famous for not meeting standards, and parts of the eastern. This is to a large extent from coal power plants and things like that. It's not from household stoves. So here is some data from NASA, estimating about 30% of the outdoor air pollution in China is due to household air pollution, and 50% in India. Not small fractions. So we're trying to argue now that for an outdoor air pollution control policy, you need to think about households too. All right, what about the climate side of this? Now, this is a little complex, I understand, but it's really a revealing figure. And this is this is from the Intergovernmental Panel on Climate Change, last publication, and this is what they call radiating forcing, the amount of warming that occurs. And these are the major pollutants that cause the warming in the atmosphere. Of course, CO2 is the biggest one. It causes the most. But there are other important greenhouse gases, methane, fluorocarbons, nitrous oxide, more fluorocarbons, carbon monoxide, organic compounds, black carbon, some other things. I want to point out that these are all products of incomplete combustion. They are contributed to by combustion in households, other places where combustion occurs. Black carbon, sort of the pollutant of the month, it's just soot particles. It's only from incomplete combustion. It's the only source. It's the main source of all the organics. It's almost the only source of carbon monoxide, and it's one of the sources of methane. There are other sources of methane. So products of incomplete combustion play a role in the climate. Now, how big a role? Obviously, CO2 dominates, although perhaps not as dominant as you might have thought. Let's see, I'm going to stick this here. This is the black carbon emissions in the world. And you notice that households, I don't know how accurate this is, roughly a third or so of total black carbon emissions come from households. So you can't have a black carbon policy unless you deal with households. And indeed, in South Asia, China, parts of the world where a lot of household fuels are used, solid fuels are used, the black carbon component is quite important. Black carbon is a climate actor. Causes warming, but also if it lands on glaciers, as you know, causes the glaciers to melt faster than they would otherwise. So it's a big concern in the Himalayas, in the Andes. In fact, we have a project now, we call it the Himalayan Transect. We're doing measurements in southern China, in Tibet, in Nepal, and northern India, kind of transect across the Himalayan glaciers to look at the emissions across that, to try to figure out how important households are in that important part of the world. Well, not just maybe 1/3 of black carbon, but also 1/3 of carbon monoxide comes from household fuels. 1/6 of ozone-causing pollutants, which is a greenhouse pollutant, a greenhouse gas, and then not an insignificant part of methane. So it is an actor, not perhaps the primary one, but still big. Well, how big compared to other things? Well, this is a study done at Goddard lab at Columbia University recently, and they compared all the major economic sectors. Here's vehicles, biggest impact on global warming. And they added up the impact of all the different pollutants from these. So carbon dioxide is there, but you can see carbon dioxide is not necessarily the biggest single actor. And there's some pollutants that actually cause some cooling. Those are on this side. Organic carbon that comes from combustion, for example. In some cases, that organic component is quite big, like open biomass burning, like forest fires and things. Forest fires are thought to be generally cooling. Some warming components, but a lot of cooling components. Well, now this is very complex to do. A lot of uncertainties require, sophisticated models. So I wouldn't, bet your last dime on the exact amount. Yes.
Could you elaborate on the negative value?
Well, these are some of these pollutants actually cause cooling. Sulfate, for example, actually reflects sunlight. And so it helps us a little bit in the climate change business. You can see the net here is, warming. But some industry, for example, to a large because it produces a lot of sulfate, is not considered a net warming contributor currently. They had to choose it. One of the things about these analyses, you have to choose a particular year. They chose 2020. You could choose a different year. That's aerosol indirect effects. That's the clouds that are created by the aerosols. And that's the most uncertain part of these models. So the small particles get in the air, they seed clouds, and those reflect sunlight. But how much is actually going to be done? That's very uncertain. I don't know. People have probably heard about geoengineering. These are these grand schemes to try to protect us against climate change. One category of those schemes is to reflect sunlight back into space. One way to do that is to put a lot of sulfate in, purposely put sulfate into the atmosphere. But of course, sulfate causes ill health. It causes acid rain. It might not be such a great idea. Another one that's interesting, however, interesting one I was at a meeting last week about, and that is you go out in the ocean and you have high-pressure pumps that take seawater and fed it up into the atmosphere. And the seawater evaporates, leaving salt crystals, and the salt crystals form clouds. That's the idea. And the clouds reflect the sunlight. Nobody's doing this yet, and there might be a lot of negative impacts as well, but these are the kinds of things that are thought about. But that's, that's the indirect effects from aerosols are the name for small particles. So I just want to point out, and according to this analysis, household biomass is second in the world as an impact on climate. Now, I'm not going to argue that it might be third, it might be fifth, but it's an actor. On the world stage. After all, there are 2.7 billion people doing this every day, more than ever time in human history, producing a lot of noxious stuff that comes out of those stoves. And so perhaps it's not surprising. All right, it's a perfect storm for health effects, of course. Highly polluting activity, half the world's households, or 40% now, several times a day, just when people are present. Most vulnerable people there, women and young children, because women have the cooking task in almost every culture, and they have the caregiving task for the youngest children. Now, one way to think about this is the intake fraction is extremely large. That means of the amount of material emitted, how much goes down somebody's throat. And this varies tremendously. What's the worst intake fraction? Can't beat this for getting your intake fraction up. 100% goes down your throat. Well, wood fire in your kitchen is not 100%, fortunately, but it's a very high intake fraction compared to releasing the smoke, down the street or out in a power plant outside of town, obviously. So this is one reason why a relatively small total fuel use can produce a relatively high effect. Obviously, the fuel, if you wanted to think of tobacco as fuel, is very small, but it's a huge impact because people stick it in their mouth. So now this is a little complex, but it's a very interesting slide. It's almost iconic slide in our field, and it basically looks at the risk of heart disease. Let's just call this heart disease, and the dose of pollution, how much goes down your throat, the intake goes down your throat, and a whole bunch of studies, different types. Here, these are all active smoking studies. People sticking this stuff in their mouth, and they're heavy smokers and light smokers. The starred ones are environmental tobacco smoke, so-called secondhand smoke studies. That's somebody sticking in their mouth near you. Not you sticking in your mouth, but your husband or parents sticking in your mouth. And then these studies are all outdoor air pollution studies. Notice that in outdoor air pollution studies, the risk is this is relative risk. So this means basically, it's about 1.2. That means people in polluted cities have about 20% more heart disease than people in cleaner cities. Not small. Not as bad, however, as people living with a smoker. They have 30 or 40%. People heavy smoking, twice as much heart disease. So it's a very interesting graph that puts all these very different kinds of particle exposure situations on the same graph. But you notice something missing, of course. It's in this colleague and I wrote this commentary, Mind the Gap. Well, is there nobody in here? Well, who's in there? That's where our village women are. So we haven't done any studies yet on heart disease. But we expect that when we do, because we know what kinds of exposures, we'll find risks, around 1.5, 1.6. So that means these village women are getting 60% more heart disease than they would if they had cleaner fuels. Yeah.
Do volcanic eruptions, both underwater and on land,
affect this?
factor in here at all?
Well, in general, the particles that are produced by combustion, tobacco or wood or whatever, are very small, and they go deep into the lungs. The particles produced by volcanic eruption are not so small, and they don't go deep in the lungs. On the other hand, there's so much stuff produced by a volcano that maybe, although only 5% is small, it still does affect things. But they're not every day in every house. I mean, they're just periodic. Yeah, so yes. So you're asking their health effects from ash from volcanoes? The answer is yes. Just fortunately, we don't have them all the time. And they also affect climate. I mean, the Pinatubo eruption and the last big one, sort of global eruption, cooled the climate a little bit. Not enough to, counterbalance what we're doing to the climate, but certainly for the, few months, cooled things a bit. So now this is, a different way of framing this work. So I'm going to put it in the same way that other graph I showed you about pneumonia. And it's actually very nonlinear too. So a small change in pollution, let's say from a chimney stove, might move you from here to here, half the exposure, but you wouldn't get you that much benefit in terms of health from heart disease. You have to start getting down here. So it's because of this kind of evidence, some you might say indirect by looking at other sources of particles, and some of our own direct data on the pneumonia, that we think that we really need to get really clean. And I'm just repeating this. This is where we want to be, down here somewhere. Well, how do we do that? Chimneys alone won't do that. Nothing wrong with a chimney, but you also have to combine it with better combustion. There have been major success stories in introducing improved stoves in the world. The biggest one, by far, is the Chinese program. They introduced 180 million improved stoves, and now numbers have to be big in China, but 180 million is even big in China. Here's the total rural population, rural households, and here's the total number of improved stoves. You see, by the time they ended the program, they'd had almost everybody had an improved stove. But these were chimney stoves, so they helped, but weren't what we now understand to be what you really want. But they do illustrate that with a consolidated, and consistent government effort over decades is what took, you can actually accomplish wonders in making changes in rural energy. This is what these these household stoves look like in China. The improved stoves, really nice things, beautiful things. Change your entire kitchen. Something you handed down to your children, you were proud of, you cleaned, it was made of, had tile on it. Not just a slight change, a mud change in the corner of some kind of improved mud stove, but a major change. And personally, I think this is the kind of thing we want. We need to. It's not a small change; it's a complete change in the kitchen.
Where is the chimney?
The chimney's built in the wall. I can't even see the chimney. So This is typical, and we're working in India now. I'm describing you an approach we have in India to introduce improved stoves, truly advanced stoves. This is typical cooking situation in this part of India. They're cooking chapati, it's like tortilla. And here, cooking on this little plate made of dough. This is the stove we are introducing. You see it's similar size and shape, but it's much nicer looking. It's got a blower in it. All of the truly advanced stoves that I know of that really achieve low emissions have blowers in them. And here you can see the control knob, and the thing is on at the moment. You can control it like gas by turning up the knob, so much more controllable than a biomass stove. It lights very quickly. You put the biomass inside, throw a match in, turn on the blower, and you're cooking in 15 seconds. Unlike a typical wood fire, you're poking and pushing and puffing to get the fire going. It has, huh?
Where does it blow the pollutants?
It doesn't create any. This is clean enough that you can have inside, and it will get you down to those levels.
Powers the blower.
Okay. Now, this particular one has a rechargeable battery that you charge with a cell phone charger. So, 70% or so of households in India have cell phones. They charge those already. So, in China, everybody has electricity. You can plug it in. In India, a lot of people have electricity part of the time, so you can use a rechargeable. But there's a new technology, I don't know if I have anything about it here, that the stove will look the same, but inside is called a thermoelectric generator, TEG, that generates electricity from the heat of the stove, operates the blower from the heat of the stove. Now, this is not a new technology. Your car, every one of your cars is filled with little TEG elements. That's how they power all the little instruments and things on your dashboard, is the TEG that are out in the engine, get hot, send a signal, use that to send an electrical signal to your dashboard on what's happening. So TEG is an old technology. It's the first time, however, it's been applied to stoves. And the guys that are marketing this stove have done a neat thing. They, instead of charging using your cell phone charger to charge the stove, you use the stove to charge your cell phone. So that provides the electricity for the blower and charges your cell phone. Now, and I think the marketing trick on that is it gets the men interested in the house. I don't think the women care about that, but it's the men. I think that's going to be a very clever marketing trick. Yeah.
How much would one cost?
Well, what do you mean by cost? You want the one now, and they made a few thousand, or the one when it's the 10 millionth one? Well, I mean, this is the policy issue. Right now, they're about $80. But Philips, this is made by Philips. You can't quite see the name here, but it's Philips, the big Dutch appliance manufacturer. Their estimate is, if you get up in the million level of a million, the price will be down by a factor of 2. From a policy standpoint, I think it's not the first one, or even the 1,000th one. It's the millionth one that you're really interested in.
How do you put the wood? Do you have to pick it up?
No, you just put the wood in there, and then when the pot is on, one downside to this stove is it requires, you can't put big logs in it, but it uses the fuel so efficiently you don't need big logs. I took one home. My wife was away, so I took one home for a week. Cooked with it, not indoors, but I did cook with it, and it's so efficient and so fast. You can actually think about boiling an egg or making some coffee or something. It's so fast that you can think of doing that. Just chopping up stuff around the yard was plenty enough fuel for it. So it's a different it's a different relationship with your fuel. But one of the issues is there's no improved device that doesn't require some behavioral change, and the question is the advantages of the thing great enough for the woman to make that change? That's the trick.
How do these people who are living very, very poor, living in rural India or China, how do they afford that?
Well, that's the question. Who should afford this? We don't ask them to pay for their vaccines. We don't ask them to pay for their, nutrition supplements for the children. We don't ask them to pay for, stopping climate change. This stove does all of those things. So part of the cost, I believe, should be borne by the rest of society. And we have mechanisms to do that. We have an international carbon market. So not this stove, but another stove we're working with, a company in El Salvador, in Central America. They have a stove called the Turbo Cocina. Those of you who know Spanish, cocina is kitchen. Turbo, it's cocina. And they're getting, that one costs 90 euros. It's made in Spain. 90 euros is pretty expensive. Those women in rural El Salvador are not going to pay for it. But they get 40 euros a year from the carbon market for every stove. Well, 40 euros a year on a 90 euro investment, you're making money. They don't even need the government. They just get private investors. And that's getting the carbon market to pay for it. Sorry, you've been...
How large and how heavy is this thing?
Well, you can sort of see. I mean, you know, it's this big. And not heavy. I mean, sturdy, but not heavy. Yeah.
How much did we improve Chinese?
Well, it's a little hard to say because that program's 15 years ago, you know, but in the order of $50 in today's money, so not cheap. But now, so what approach are we taking to dissemination? Well, what are the modes? How do you disseminate? You can sell it to people. Or you can, you know, have geographic. You could choose areas that are especially interesting because maybe there's deforestation. You can do a commercial one where you just sell to people. And then maybe these are the, you know, what the government might do. But I actually, as a health person, I'm not interested in selling to people because who are you selling it to? You're always selling it to the richer people first. And they aren't the most vulnerable. These may or may not be vulnerable. I mean, this is more, you know, targets of convenience or often politics. I want to get at this vulnerable group. How do you get at the vulnerable groups? Well, in public health, we're used to getting at vulnerable groups. Now, there's some vulnerable groups that are obvious, refugees, disaster victims. So there are improved stove programs in Haiti. There are improved stove programs in Darfur. Those are special vulnerable groups, easily targeted. I mean, you know, at least you know where they are. But so those are special groups. That's not what I work on. I want to work at the people at the bottom of the income pyramid in India. How do we get at them? Well, I think we have a clever idea, but we have to try it out. Skip that. Well, here's the idea. You don't want to start at the top of the income pyramid. That's fine. It's okay to start there. Build up a market for better stoves. That's fine. But I want to get down here. And you're not going to buy $80 stoves. Can't even talk about it. Remember, it's this group here, the poorest group. All right. So we examined, I'm on this committee in India, they have a new national cook stove program, and we're trying to think of how to get at vulnerable groups. Well, one way is the rural housing program. They're building housing, you know, for people, and might as well put an improved stove when you build a house. It's actually a small fraction of the house value. But that's only getting, you know, $100,000 a year or something. It's not really very big. They're trying to electrify the entire rural population. If you have a blower stove, it's natural maybe to include that as part of the electrification program. Well, that's an option. One of the biggest scandals in the world, I think, is that, you know, 60 years after independence in the biggest democracy in the world, they still don't, you know, educate their rural women. But they're trying to fix that. That could be, maybe you could provide that as a sort of incentive for the women to go through the literacy program. That's an option. But the one we're working on to the antenatal care system. Now, antenatal care is the jargon term in public health for prenatal care. Well, India has a pretty good antenatal care system. It reaches 80% of poor rural women. It's very highly targeted because you know, middle-class women, richer women, they don't go to public clinics, they go to doctors. We're not going to disseminate through doctors, we're disseminate through public clinics. These women are already getting a package of benefits. They're getting iron pills and folic acid tablets and nutrition supplements and hygiene education, and you know, they're already identified. They're in the system. And one thing about working with pregnant women is you don't cause political problems in the village of giving it to one group and not another, because everybody knows that pregnant women are, you know, a special group. So we think it's a very good way of subsidizing to a group without having to, you know, go through the usual problems of subsidies. And so this is one of these workers that work with pregnant women in the village. I think this is, you know, she really liked this stove, as you can see. But this woman, you saw the picture of the other important woman in my life in terms of this field, Meghana, the first person to be have her. This is second most important woman in my professional life, because she told us we were talking about these stoves wrong. She says, "Don't talk about it as improved." I'm going to put some words in her mouth, but basically she said, "Don't talk about it as improved. You know, you go to the drugstore down here, you go to CVS, every single thing on the shelf is called improved, right? 30% more cleaning power. What, you know, who cares? I mean, you don't, does it mean anything to you? No. Why should it mean anything to a villager? They see the same stuff. He said, don't try to distance yourself from the bad thing, but associate yourself with the aspirational, the good thing. Say, it's almost like gas. Everybody wants gas. They see gas in the movies. They see their rich neighbors with gas. Make it so it sounds like you're getting into gas. It's modern like gas. It's controllable like gas because it has the controller. It's cheaper than gas, cheaper to run than gas. It's almost as clean as gas. Not as clean, but almost. It cooks faster than gas, actually, the studies show. You can get a higher power with it than the gas stoves. It won't explode like gas because there's this worry that the cylinders explode, and they do occasionally. So, you know, but it's a very different framing of things to think of it. And then somebody reminded me, you know, something that my father used to always say back in the 50s, now you're cooking with gas. Remember that expression? You don't hear it much now. But, you know, so and the idea, it didn't have anything to do with cooking. It was now you're doing something efficiently and modernly, you know, and so on. Where did that expression come from? So I looked it up. And that great, you know, research tool called Wikipedia. And it was an advertising slogan from the gas industry back in the 1800s when they were trying to get women to move away from wood and coal. Now you're cooking with gas, lady, you know. So, but in the improved this world, we haven't had a stove that you could honestly call was like gas until recent. So this class of blower stoves and with fans in them. Now we can actually, with a straight face, say it's almost like gas. It's modern, it's fast, it's convenient, it lights quickly. Even better than gas, cheaper to operate. It doesn't explode. Not quite as good as gas, and the one main thing that's not as long-term unintended cooking. You know, you can turn the gas thing on and leave it. This, you know, you have to feed the fuel, so that's a downside to these. But in any case, so that's what we're doing. We're introducing improved stoves, or advanced stoves or gas-like stoves through the antenatal care system in India. And going to measure the pollution changes, measure the effect on the birth weight of their children. The outcome we're interested in is to Indian women, for some reason, have quite high rate of low birth weight, more than 40%. So that on every child born below 2,500 grams, you know, 2.5 kilograms, is very vulnerable to ill health as a child, and even now I recognize as an adult. So the Health Ministry has told us if we can show that these work to lower the rate of low birth weight significantly, $80, that's okay. We don't care. They're already paying $100 of benefits to these women. So $80 more, or if we can get 1 million of them done, $40 more, that's not a constraint. So you ask about cost. Cost to whom? For what? If it has the health benefit, that's not even counting the climate benefits that we might be able to get paid for. So that's the approach we're taking. It's truly advanced stoves, introduced to the most vulnerable groups, but we still have a ways to go to convince the authorities that it's worth putting in as a regular thing in the antenatal care program.
How long does it last?
Well, it has a guarantee of 3 years warranty. Probably doesn't last too much longer than that. But we don't know. I mean, they haven't been on the market long enough. It's Philips, so it's good warranty. I mean, they'll just replace it for you. It's the first big company, you know, with an international reputation that's gotten into this business, which I think is a good thing. All right, so this is the last slide. Now, for this part of the world, you've heard of, you know, Thoreau, I'm sure. In Walden Pond, he has this, you know, wood is the fuel that heats you twice. Once when you chop it, and once when you burn it. But he was wrong. It's actually heats you 4 times. The fever from the respiratory infection and the global warming. But better combustion will get rid of the last 2, and we can get back to the original only 2 warmings from wood. So thank you very much.